Well, hello everybody. What I need to do with you today is I need to cover Day 2 in Chapter 6 over the multiplication counting principle. We will also talk about permutations and what's called combinations. I'll define those as we go along today. And of course there'll be an assignment towards the end. What you need in front of you today is you'll need your Day 2 note worksheet so that you could follow along, and you'll need a calculator because I'll show you a couple of keys on your calculator today once we discover it's a permutation or a combination. So I'm going to preface just a couple of things real fast. Some terms that you're going to hear today, you're going to hear what's called the multiplication counting principle. What that is, guys, it's a shortcut to what you learned last class. It's a way to figure out the number of outcomes, the number of different outcomes when you're dealing with a set of data or a set of people or a set of objects. So it's a way to figure out the number of outcomes. You're also going to hear the word permutation today. What's meant by permutation is that you're working with a group of objects, but order matters. You're going to hear the word order a lot today. Here's what I mean by order. If you are with a group of friends and you're trying to pick a president, vice president, order matters because President Trump, Vice President Pence is totally different than President Pence, Vice President Trump. So you can't flip the order around. If you're running a race, there's a big time difference between first and second. If you're the first one across the finish line, you want to get credit for that first place finish. That's what I mean by order, when order matters. You're also going to hear the word combination today. A combination means that you're working with a group of objects or people, but order does not matter. So for instance, a group of you decide to walk down to the candy machine and get something to eat. There's no order there. There's no first place, second place, third place. It's just a group of friends going down to the candy machine. Or since basketball season's firing up, Coach Keltner can put his starting 5 on the court. Well, order doesn't matter there. 5 of his 12 people started the game. So that's what we're going to mean by permutation and combination. You'll see those down the way. So those are the 3 items that I'm going to cover with you today. So if you would, flip over to your class notes. It says Day 2 class should look just like that. And I'm going to talk to you about the multiplication counting principle. Now, I've cheated a little bit and already typed in a few things just to speed the video up. So here goes your number 1. Assume that for lunch today you have the choice of a steak or a chicken breast. It's a good lunch today. Green beans or corn. Mashed potatoes, baked potato, or scalloped potatoes. If you choose one item from each category, how many different lunches are possible? Now, some things we're going to assume. We're going to assume you're going to take one item from each category. You don't get 2. You're not going to pay for extra. You're not going to skimp on your vegetables. You're going to take one item from each. Well, guys, what I've done on here is I've already listed every possible combination that we could have. Here's what my letters stand for. You could pick the steak, and then you could pick green beans, and then you could pick mashed potatoes. That's one possible meal. A different meal would be right below it. You could pick a steak, green beans, and then a baked potato, or you could go steak, green beans, and then scalloped potatoes. Notice I've already got 3 different meals already. Now, you could also go with the steak, corn, mashed potatoes, steak, corn, baked potato, steak, corn, and scalloped potatoes. So I just added in another 3 meals. So I'm up to 6 already. And you can kind of see where I went here. You could go chicken breast, green beans, mashed potatoes, chicken breast, green beans, baked, chicken breast. So you kind of get the idea. This is all the possibility of those. Notice, guys, that there happen to be 12 of them. There are 12 different combinations that we could come up with. Now, the hassle part is I listed them all, but here's a shortcut for you. We're going to pick from 3 different categories today, so I'm going to put 3 blanks. Now, we're going to consider each category. So the first category, you get to pick between a steak or a chicken breast. So how many choices would you have? Well, you got 2 choices. You could have the steak or the chicken. Now let's move to the next category. You could have green beans or you could have corn. Another 2 choices. So you're going to hear the word choices a lot. Now, let's come back down to the potatoes. Mashed potatoes, baked potatoes, scalloped potatoes. There's an additional 3 more. Well, here's why it's called the multiplication counting principle. 2 times 2 times 3 happens to be 12. There's 12 different meals possible with this scenario. We can make it a lot tougher. I could ask you what kind of dessert you wanted, what kind of milk you wanted, or drink, but that's the concept. We're going to go choices times choices times choices. So here goes your number 2. Annie has 3 skirts, 7 tops, and 4 pair of shoes. How many ways can she make an outfit? Well, some things we're going to assume. In Annie's outfit, she's going to pick a skirt, she's going to pick a top, and she's going to have a pair of shoes. Well, in terms of the skirts, she has 3 choices. In terms of the top, she has 7 tops. She has 4 pair of shoes. If we multiply those all together, we get that she could come up with 84 different outfits. So choices times choices times choices. So there's what we got so far. Now, let's move on to number 3. It says, assume that you're taking a quiz that consists of 3 true-false questions. How many different sets of answers are possible? Well, we're going to do this 2 ways. We're going to list them, and then we're going to look at it via the multiplication counting principle. When you list everything that could happen, we want to stay organized on your work. So, here's how I'm going to organize the work. There's 3 questions. I could answer true on the first one, true on the second one, true on the third one. There's only one way to list all of them as true. Now, let's pick on the number of ways to list 2 trues. Number 1 could be true. Number 2 could be true. Number 3 could be false. Number 1 could be true. Number 2 could be false. Number 3 could be true. I could also let number 1 be false, number 2 be true, number 3 be true. So I'm up to already 4. This was 3 trues. Here's a little group with 2 trues. Now let's list all the ways to get 1 true. Number 1 could be true. Then I could go false, false. I could go false because question number 2 was true, and then false again. I could also go false for number 1, false for number 2, true for number 3. So there's all the ways to get 1 true answer. And then, of course, to get 0 true answers, they all could be false. So guys, what I know, there's 8 different outcomes on this quiz or test. The shortcut to it, 3 questions. I had 2 choices on number 1, 2 choices on number 2, 2 choices on number 3. Once I multiply those together, I get 8 different outcomes. While I'm here just to plug it a little bit, the chances that you got them all right would be 1 out of 8. Doesn't matter what it was. If the correct answers went true, true, false, which had been right there, that showed up 1 time out of the 8. So, choices, choices, choices. Here's your number 4. A quiz has 10 questions. Each question can be answered as always, sometimes, or never. How many different sets of answers are possible if you guess on each question? And then what's the probability of answering all the questions correctly? Well, let's think about this. Technically, I've got 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For question number 1, I have 3 choices. For question number 2, I have 3 choices. 3 choices for number 3, you kind of get where I'm going with that. Notice that I'm going to have 3 choices 10 times. So if I take 3 to the 10th power, that means there's 59,049 different sets of answers. You'll also hear a little formula I'll say in class. Whenever it's a test question, if you can always take your number of choices raised to the number of questions. You might write that down by your number 4. We'll use that a couple of times. The number of choices times the number of questions. This little formula only works on test questions, quiz questions. Now for the second part, if you were clueless, you walked into that class and you guessed on all 10 questions, the chances that you got 100% would be 1 out of 59,049. So pretty dang slim for you to get 100%. But there's where we are so far. Come over to your next. Assume that a pair of 6-sided dice are rolled. One dice is maroon and the other is gold. The reason I'd like to give dice colors so that you could see a gold 5 and a maroon 2 is totally different than a maroon 5 and a gold 2. If you took a picture of it, they would be totally different. So here's where I want to go first. It says how many sets of possibilities are possible? Well, I've got 2 dice. On the first die, I have 6 choices. On the second die, I also have 6 choices for a total of 36 different outcomes. So 36 different outcomes. Now, my part B says find the probability of a sum of 7. Notation that you have not seen yet today. P for probability, and here is what you're trying to figure out the probability of. Well, here's how we're going to attack this. I have a maroon die and a gold die. Let's list all the ways to get a sum of 7. I could get a maroon 6 and a gold 1. Or I could get a maroon 1 and a gold 6. Because if you took a picture of it, it's totally different. I could get a maroon 2, a maroon 5 and a gold 2, or a maroon 2 and a gold 5. I could get a maroon 3 and a gold 4, or a maroon 4 and a gold 3. That's all the ways to get a sum of 7. Well, 1, 2, 3, 4, 5, 6. There's 6 out of 36 ways to get a sum of 7, which reduces to 1/6. Here goes my C. Find the probability of a sum of 11. Well, let's go a maroon die and a gold die again, and let's list all the ways to get a sum of 11. I could get a maroon 5, gold 6, maroon 6, gold 5. That looks like it. So 2 ways to get a sum of 11 out of 36 total outcomes, which reduces to 1/18. Okay, so you probably get the hang of this now. The probability of a sum of 8, so let's go maroon and gold again. However you want to organize it, maroon 6, gold 2, and I can flip those to a 2 and a 6. I could get a maroon 5 and a gold 3, or a maroon 3 and 5. I could also get a maroon 4 and gold 4. Now be careful, I cannot list that again. If I try to list a 4 and a 4, the picture would be the same. I'm going to see a maroon 4 and a gold 4, so don't get to count the double. So 1, 2, 3, 4, 5. 5 out of 36. And then on E, the probability of a sum of 13. Well, if you think about 2 dice, the highest I could ever roll is a 6 and a 6, which gives me a sum of 12. So the probability of me rolling a 13 is 0. 0 in probability means it cannot happen. So don't put empty set, it's called 0. So scroll over, I'm going to switch gears on you just a little bit. Here comes the permutations and combinations. I'm going to show you a couple of ways on this. It says, assume that there's 4 people in a group. There's Abby, Betty, Chance, and Delton. I picked those names for a reason, you'll see. List all the ways that a president and vice president could be chosen from this group. So here goes. I'm just going to use initials, so will you. Abby could be president. Betty could be her vice president. Abby could be president. Chance could be her vice president. Abby could be president, or Delton could be her vice president. Well, now let's move to Betty. Betty could be president, Abby could be vice president, Betty could be president, Chance vice president, Betty president, Delton vice president. Now let's let Chance be president. There could be Chance and Abby, Chance and Betty, Chance and Delton. Now let's go pick on Delton. Delton could be president, finally. Abby could be his vice president, or Betty could be his vice president, or Chance could be the vice president. Well, check this out, 12. So there's 12 different ways that this could happen. Guys, this is called a permutation. The reason that it's called a permutation is that order matters. What I mean by order, if you switched any of those around, you got a totally different outcome. They're ranked there for a reason. Now, I'm going to show you two ways to do this. One with your calculator and one just thinking through it. I'm going to do it by choices and choices, tying in the multiplication counting principle. Right now I got 4 people that could be my president. After I pick my president, though, they can no longer be the vice president also. So after I pick my president, let's say Delton, there's 3 more people that could serve as a vice president. So 12. Another way, if you recognize this as a permutation, your calculator can help you out also. It's going to look like this. I have 4 people in my group to choose from. It's a permutation, and I'm going to pick 2 of them. So the way to let your calculator run this through is I'm going to hit the number 4. I'm going to hit math and go over to probability. And then I'm going to come down to the NPR, which means the number of objects that we're working with picked are different ways. So I'm going to hit that, so this shows up on my calculator, and I'm going to hit 2. So here's what this is saying to your calculator. I've got 4 objects, and order matters. That's why I picked the P, and I'm going to take 2 of them. Once I hit enter, notice that it also gave me 12. So 3 ways to get the answer there, guys. Normally, if you look at my answer keys, I usually don't use my calculator, so I won't do that. But I try to write that out so you can see what it would look like. Here goes B. Now they will line up to race the mile. List all the ways the top 3 could finish. Now, I'm not going to list all of them because of the video, plus there's 24 of them. I'm just going to show you how I knew there's 24 of them. Method number 1. I'm going to put 3 blanks because I'm worried about the top 3 finishers. We're assuming no ties. 4 people could win it. After we know the winner, I've got 3 people fighting for second. After I know who's second, I still got 2 people fighting for third. 4 times 3 times 2 tells me that there's 24 ways they could finish first, second, and third in the mile. Now, once your calculator do the work for you, I'm going to go 4, P for permutation, and I'm taking the top 3. So it's going to look like this. 4, math over to probability, down to NPR, and I'm going to pick 3. 4 objects taken, and I'm going to take them R at a time. Tells me that there's 24. So 2 ways to get the answer, guys. Here's kind of the fastest if you think about it, but this is a legit way too. Now, on part C it says, now 3 of the 4 will go out for ice cream. How many ways can this be done? Well, I've now got 3 friends going out for ice cream. I'm going to list them because there's not that many. I could let Abby, Betty, and Chance go out for ice cream. I could let Abby, Betty, and Delton go out for ice cream. I could let Abby, Chance, and Delton. Or I could let Betty, Chance, and Delton. In this one, guys, there's no order, there's no ranking, there's no importance. So order doesn't matter. So notice that there's 4 here. This is called a combination. A combination means order doesn't matter. It's just a group of friends doing something. What's this going to look like in terms of your calculator? I've got 4 friends. It's a combination, and order doesn't matter. So guys, we're going to type that in your calculator the same way. 4 math over the probability, and instead of NPR, it's NCR for combination. I'm going to take 3 of them. And hopefully my calculator shows me that the answer is 4. Now there's formulas for a combination and a permutation that I want to show you. They're on the back side of your sheet. So flip back over if you would. Now we're on that back side. Here's the permutation formula. When we type in NPR, what your calculator is doing this. This is the total number of objects. The R is a number that you're taking. I tried to figure out why they used R, but it didn't make a lot of sense to me. So I'm going to show you calculator and non-calculator. So 6P4, it really means this. 6 factorial over 6 minus 4, so 2 factorial. N was 6, R was 4, so this is 2 factorial. Now, you have not seen the factorial key yet. Here's what factorial means. If you ever see the 6 factorial, it means 6 times 5 times 4. I don't know why I wrote 3. It means 6 times 5 times 4 times 3 times 2 times 1. It means start with that number, keep them all integers down to 1. So now, if you think about what we got, 2 over 2 cancels out and 1 over 1 cancels out. I'm left with 6 times 5 times 4 times 3. So it looks like I'm at 30, 120, 360. I want you to know how it comes about. Calculator-wise, guys, it would have just looked like this. 6 probability down to NPR, and I'm going to take 4. That way we can match it up. Down the road, I'm going to give you some where your calculator can't do it for you. So, here's my B. By formula, it means 10 factorial over 10 minus 3 factorial. So that'd be 7 factorial. You could type it in your calculator and you're going to get 720, but I want you to see what it means. It means 10 times 9 times 8 times 7 all the way down to 1. But let's look at what 7 factorial means. 7 factorial means 7 times 6 all the way down to 1. Well, this block of numbers is going to cancel out, leaving me with 10 times 9 times 8, which is going to be 720 different ways. So you got 2 methods. You can think through it. I want you to at least know where the numbers come from, but you can use your calculator. Now let's look at C. It's a combination formula. It's a tad different. That's going to mean 10 factorial over, now it says the number of objects you're taking, which is 3 factorial, times 7 factorial. I got that 7 from 10 minus 3. Now, I'm going to show you how to do this without your calculator. 10 factorial we know means 10 times 9 times 8 times 7 all the way down to 1. Let's look at what 3 factorial means. It means 3 times 2 times 1. But 7 factorial means 7 times 6 times 5 all the way down to 1. Well, look at this group of numbers right here, guys. They're going to cancel out. So those are gone. So I really have 10 times 9 times 8 divided by 3 times 2, which is going to give me 120. Once again, you can always type that into your calculator. Come over to your number 8. We are really close to done with this video now. We just got to decide if it's a permutation, combination, or a multiplication counting principle, and then go get the answer. So here's number 8. The ski club with 10 members is to choose to choose 3 officers, a captain, co-captain, and secretary, how many ways can those offices be filled? 2 ways. I need you to recognize that this is a permutation. The reason it's a permutation, I'm giving them a rank. I'm going to give them a rank. Captain, co-captain, and secretary. If you recognize it as a permutation, you'll say there's 10 people to pick from. It's a permutation, and I'm picking 3 of them. If we run that through our calculator, 10 math over the probability down to NPR pick 3, notice that the answer is 720. Then we're really done with that problem. Another way to get it, choices times choices times choices. I've got 10 people to choose from for my captain. After I pick my captain, there's 9 people. After I pick my co-captain, there's 8 people. 8 times 9 is 72 times 10 is 720 different ways for me to give them that. But the key thing there, guys, I need you to understand that it was a permutation. Here's number 9. The company Siesta has 10 members on its board of directors. In how many ways can they elect a president, vice president, secretary, and treasurer? Once again, we're giving them order. We're ranking them. So that's important. If you want your calculator to do the work for you, I've got 10 people to choose from. It's a permutation, and I'm picking 4. If you want to use the blanks, I'm picking 4 officers. I've got 10 people to pick from, and then 9, and then 8, and then 7. Either which way, you're going to get 5,040 different ways to pick a president, vice president, secretary, and treasurer. So guys, you just got to decide if it's a permutation or a combination. Here's my number 10, 11, and 12. An election ballot asks voters to select 3 city commissioners from a group of 6. In how many ways can this be done? So you got to decide if this is a permutation or a combination. Notice that we're not giving them order. We're not letting them run a race. We're not selecting them as president, vice president. So this would be a combination. So when I set this up, I've got 6 people I can choose from. It's a combination, and I'm picking 3. So let's go 6, math, probability, NCR, picking 3, 20. So I know that there's 20 different ways that this could be done. Here's our number 11. A 4-person committee is to be elected from an organization's membership of 11 people. How many different committees are possible? So look through there and see if there's any area where we're giving them rankings. If there's no rankings, it's a combination. So I've got 11 people to choose from. It's a combination. I'm picking 4. Run that through a calculator. We're going to get 330 different ways for that to happen. Here's my number 12. For a segment of a radio show, a disc jockey, Dr. Jams, can play 4 songs. If there are 8 to select from, how many ways can the program for this segment be arranged? Well, think about that one a little bit and decide if you think think if order matters when you listen to the radio. Since he's got 4 songs, he's ranking them. He's going to play, really he's got 8 songs and he's going to pick 4 of them. He's ranking them. He's saying one of them is his favorite. The next one's his second favorite. The next one's his third favorite. So order would matter. So 8 permutation 4, or I'm picking 4 songs. I got 8 choices for the first one, 7 for the second, 6 for the third, and 5 for the fourth. Once I multiply those together, 1,680 different ways for me to rank those music. Okay. And then it looks like I got just a handful left. Here's number 13. You are on your way to Hawaii. Aloha for you. And of 15 possible books, your parents say you can only take 10. How many different collections of 10 books can you take? Well, if you think about this one, you're not ranking them as your first favorite, second favorite, third favorite. You just get to take 10 of the 15 books. And then you can decide how to read them after you get going. So in this case, this is going to be a combination. I got 15 books to choose from. It's a combination, and we're going to pick 10 of them. Run that through a calculator. I'm going to get that there's 3,003 different collections that he could come up with. Guys, the reason I used the word collections is it was used right there. Here's our number 14. To win the small county lottery, one must correctly select 3 numbers from 30 numbers. In order to the order in which the selection is made does not matter. So if the winning numbers were 10, 15, and 20, but you had 20, 15, and 10, you still win. How many different selections are possible? Really, the lottery is the world's largest, number-wise, combination. Order doesn't matter in the lottery. But so in this one, we got 30 numbers to choose from. It's a combination, and you're going to pick 3 of them. There would be 4,060 different ways for this lottery. And then last but not least, guys, in a production of Grease, 8 actors are considered for the male roles of Danny, Kinnicky, and Marty. In how many ways can the director cast the male roles? Now in this case, order would matter because Danny was that lead guy played by John Travolta in the early days. So order matters in this case. So I've got 8 actors to pick from. Order matters, and we're going to pick 3 of them. Or, since order matters, I could go, I'm picking 3. I've got 8 guys to pick from, then 7, then 6. No matter which way you do it, you're going to get the same answer of 336 different ways. So guys, that is day 2 in chapter 6 and 10. Good luck with your assignment. Come in if you need any help.